So I'll get started. Once again, thank you for coming to our little space at PingCap. It's a pretty big space, but we only have a small piece of it. And like you mentioned, I used to work at the Obama White House, but we're talking about tech today, so I just have to always say Obama these days because there's another guy who lives there now. But politics hurt people's feelings, so I won't talk about it. If you want to know how I feel about it, just follow my Twitter account. It'll be very obvious. Okay, but today we're talking about TiDB and how it helps Mobike, which is one of the largest dockless bike sharing platforms out there, scale its infrastructure so it could scale to the size that it is now, which is quite massive. So quick agenda about today's item. I'm going to go through a quick history about the company, the community. We'll do a pretty in-depth technical overview of what the product is all about. I will do the use case with Mobike. And I will also do a quick demo. I like to call it DIY HTAP, so do-it-yourself HTAP. HTAP obviously stands for Hyper Transactional Analytical Processing Database, which is the kind of database that TiDB is as well. I'll do that on my local computer with Docker Compose, so everyone can kind of get a feel of it. Obviously, don't do that for your in-production environment, but it is fun to play with. And then we'll do some Q&As, okay? So quick history about the company. It was founded in April 2015 by 3 infrastructure engineers. They all worked in some of the largest internet companies in China, like JD.com and NetEase, and they broke out on their own because they wanted to make a database that really solves all the problems that they couldn't solve with any existing product when they were infrastructure engineers. And 3 years later, we now have TiDB, which is a platform. Ti just stands for titanium, for those of you who are wondering. It's not like anything weird or crazy. We have 3 components in there. One is TiDB itself, which is actually a stateless SQL layer that's compatible, not compatible, with MySQL. We have TiKV, which is a distributed key value store that's underneath TiDB. We also have TiSpark, which is a Spark plugin that allows our users to run complex OLAP queries. And that also sits on top of TiKV, which gives you this HTAP capability for our users. And I'll go into what each of the pieces are. It was open source from day one. We released our GA 1.0 in October of last year. And we're actually getting close to releasing our GA 2.0 as well, just within probably the next week or two. So please follow our Twitter account, and you will get the news when we break it. Okay? So a quick overview about the community. So all of our founders, myself included, everybody in the company are just huge open source fanatics. So we are very, very invested in building a strong community around this product. And luckily, the community has responded quite favorably to what we've been doing so far. We have a very strong star count on GitHub, and always growing. This is the number that I checked just earlier this afternoon. And we just started our US presence, actually. So we really started building out this office in the last 4 to 5 months or so, and also hitting up quite a few news publications. Our engineers love to write, so we try to get them published wherever we can. So check out some of our articles out there as well. But these are the core features of TiDB. And I hate reading slides, so I'll just kind of have you guys read through these features, but really we'll go into each of them in detail. Just a quick show of hand though, how many people are using MySQL at work or for fun? Cool. Awesome. Yeah. So right now our product is MySQL compatible, so it really serves as this kind of pretty easy drop-in replacement for MySQL deployment that is running into a lot of scalability problems. And this is the overall architecture of TiDB, and it looks like a little complicated, but honestly it's not. So we'll take our time with this. But essentially, this is the TiDB cluster. This is the stateless SQL layer that's compatible with MySQL. And on top of that is all your application that talks to it. So you can imagine these as a bunch of MySQL servers or masters in there. And then TiDB are the slaves of these MySQL. And all the data is actually stored in the TiKV cluster that's distributed over here. And on the right side, which is TiSpark, it's pretty much the same thing, except with Spark SQL. And that's what you use to run a lot of the complex OLAP queries. And I'll go into a little bit more about how we leverage Spark in the TiSpark component. And what is managing a lot of this stuff is actually what we call PD, that just stands for placement driver. It's actually a cluster of placement drivers that stores a lot of the metadata. It does a lot of the data location a lot of kind of the auto scheduling policy, a lot of load balancing, a lot of the functionalities that typically you might do manually before happens kind of dynamically in here. And it works very closely with other TiDB clusters. And I'll talk more about that in detail as well. But this is kind of like the overall architectural structure of the entire thing. So how do we make TiDB work? So TiDB is basically SQL on top of the TiDB cluster. So these are kind of breaking it down into what exactly goes into TiDB. So we of course have the MySQL protocol that's compatible, but in theory you can plug in really any kind of database connectors on top of it to make it work. MySQL parser, we also have a cost-based optimizer that really optimizes the kind of query plan that should be employed depending on what the SQL query actually is. And all this stuff we actually made from scratch, so it took us a pretty long time to really build this out together. And then underneath it, you have TiDB. And in TiDB, we use Raft consensus protocol to provide the data replication and also the consistency as well as the high availability feature. And for those of you who have never heard of Raft before, it's just this pretty straightforward consensus protocol where you have a piece of data. So you can think of each these colors that are the same color as one Raft group. They're always an odd number. They will elect a leader within the group that serves the data, while the other two, or it could be the other four, as long as it's an odd number, are the backup, right? In case the leader fails, you elect another leader, and then everything is okay. And then what we do is that we break up all the data into little chunks that we call region. It's kind of just this term that we came up with. So if you read our documentation, use the word region a lot. But these are just little regions that make up a bunch of Raft groups that get distributed amongst a bunch of TiDB nodes. Okay? And this is a simple illustration of how we map essentially relational tables into key values. And essentially, on the key value side, we just append table ID, I think row ID, and a few other index information to be a key. And then the value part is all the value that are in your columns. And the way you can visualize TiDB is just this giant map, essentially, that are broken down into regions that become Raft groups. Okay? And this is an illustration of how TiSpark works. And we do leverage a lot of the Spark's own execution plan. It is a very powerful platform that's very popular these days for complex OLAP queries, analytics, machine learning. But we also add a lot of our own stuff so that it works really well with our TiDB clusters that has capabilities and features that, say, HDFS won't be able to let us do. Right? So that is kind of how we leverage the whole thing all on top of TiDB. And as you can tell, the TiDB part is pretty fundamental to how this entire ecosystem really works. And we've always designed TiDB to be on its own, essentially. So if you visit our PingCap repo on GitHub, it's in its own repo. It can be used independently. It doesn't have to be used with TiDB or TiSpark. And some of our users right now are actually using TiDB just on its own because they want to build other things on top of it for their own use case. And that is all good with us. And underneath each TiDB instance is also an instance of RocksDB that does a lot of the storage. And this is a quick illustration of some of those features that I talk about. One of them is dynamic splitting and merging. So as a general kind of best practice, we don't recommend having each region be either too big, which could create a lot of problems when it comes to hotspots and other performance issues, or too small. So we can actually dynamically split up a region, say region A, that is way too big. Right now, the default value is 96 megabytes, but that's a configuration you can change. Split it up and put it into, kind of spread out into your TiDB cluster. So TiDB2 isn't bored and not doing anything, and actually do some work. And in the reverse direction, if a region is too small, right now that default value is less than 10 megabytes, then we will look for the closest adjacent region to merge them into something bigger so we can make more efficient use of the storage. And in terms of hotspot rescheduling, so TiDB cluster works very closely with the placement driver cluster, like I mentioned. So there's constantly kind of heartbeat messaging going back and forth to tell you what's going on inside a certain node. And here, the blue chunks are the leader node, or the leader chunk for a graph region. So TiDB1 is getting all the workload right now. This is becoming a hotspot. That's something the PDs can detect, and it can instigate a leader transfer within Raft, so that in the resulting scenario, region B now has a new leader that is on TiDB2 as opposed to TiDB1, and now the workload is much more balanced. And some of you might be wondering, do we support join in this whole thing? Yes, we do. We support 3 kinds of join, and they're selected based on a cost-based optimizer that was part of the layer in TiDB that was mentioned in the previous visual. And in terms of transaction model, we use what this thing called timestamp oracle, which is based on one of Google's paper called a percolator. And there is issues with this implementation as well, particularly a single point of failure, which is why we actually have a PD cluster as opposed to just one node being the metadata storage. Thus, up here, there's actually 3 of them, or it could be 5 of them as opposed to just 1 of them. Right? So you might be wondering, like, okay, this is all great, like, who cares? We want to make this be cloud native, but that's something that everyone is doing quite a bit. So we're going to integrate this with Kubernetes on top of all the existing public cloud vendors going forward. Right now, we have an Ansible plus Terraform deployment scenario that you can already deploy onto pretty much all the public cloud vendors that you can use out there. But we want to make that even simpler for people to use. And as far as being who cares is concerned, ever since we released our 1.0, we have now over, I think, 150 in production use right now. This is a obviously incomplete list of the companies that are using us. Of course, being the fact that we started out in Asia, a lot of these companies are Asia-based tech companies. A lot of these logos may not be terribly familiar with you, but I do want to highlight just a couple of them. One over there in the corner is, of course, Mobike, which I will talk about more detail in a little bit. Another company here is called Ele.me, which it means "Are you hungry?" in Chinese. And it's basically a Postmates or DoorDash type service, except much larger. I think they were just acquired by Alibaba for $9.5 billion a couple weeks ago. So they were kind of in the news recently. Another big user we have here is called 今日头条, which just means headlines. It's this really cool, sticky news aggregator app that is just like blowing up in Asia right now. It's more sticky than WeChat. It's more sticky than Facebook. People spend like more than an hour using this thing every single day. So I don't use it personally, but for our sake, it generates a lot of data, which makes our use case very strong. So these are some of the marquee use case that I want to highlight for everybody. And we will actually have a lot of use case stories that we're going to publish very soon in the future, talk about how they use TiDB as well. All right? So let's dig into what we do for Mobike. So quick primer on Mobike for those of you who aren't quite into the whole like dockless bike sharing world. I'll just give you a little bit of flavor of how that actually works. Essentially, you have these bikes that have a QR code on them, and you just scan them to unlock it. You ride it to wherever you need to go. You scan it to lock it, and then you're done. Right? They're dockless. You can put them anywhere you want. Mobike is probably one of the largest, if not the largest one right now, but there are a bunch of other services actually out here in America that is also doing the same thing now. There's a company called Linebike and other sorts of similar services. And for Mobike, they have a huge user base, more than 200 million people. They're in 200-something cities or so. They operate 9 million of these so-called smart bikes. And ultimately, the one number that we really care about is that they generate just a ton of data every single day by operating this kind of services, right? So let's see how they are using TiDB. So the first scenario in which they're using TiDB is this unlocking and locking scenario. So as you can probably guess, this particular transaction is very critical to the user experience of a Mobike user. If you screw up that, interaction, there's no point in using this thing, right? So this interaction generates a huge amount of data, and we are currently supporting this kind of storing, but also helping Mobike look through the success rates of unlocking, locking, to be able to quickly identify where are your defunctional bikes that you need to identify right away, so that you can, number one, compensate the user for having a bad experience, and number two, of course, identify the bikes you can get it fixed. And the second scenario is more of a real-time analytics scenario. So like I said, with the combination of TiDB and TiSpark, they can do a lot of analysis on top of their existing MySQL deployment to be able to do real-time analytics. They're also using a proprietary tool that we came up with called Syncer. So that is technically not open source. That helps them kind of sync up their MySQL master with the TiDB cluster underneath, so everything works seamlessly together. They considered a Hadoop plus Hive approach, but decided to use our offering instead. The third one is a really cool, interesting one, I think. So Mobike has this thing called Mobike Store, where it is essentially this really cool engagement or loyalty program where they reward you for riding your bike a lot. If you go take a bunch of trips all the time, they're going to give you these points that you can actually convert to merchandises or discount coffee, kind of depending on where you go or where your travel route is. And to make that loyalty program work, it has to be on pretty much 24/7. All the data has to be stored permanently. It has to be able to handle a lot of high concurrency use cases, especially during huge promotional campaigns and that kind of a thing. So they're using TiDB to support this system as well. And lastly, this is a little bit related to the first scenario, but they generate a lot of log data, not just the locking and the unlocking back and forth, but also parking history, people's use cases or their mileage, all these kind of information. So we keep their logs as well, so they can do a lot of analysis on top of that information and even develop new services on top of it. All right. So with that, I'm gonna get into my demo. So just to set the scene on this demo real quick, so I'm going to deploy a TiDB cluster on my local machine, just so you guys can see how easy you can play around with this. And then I'll have two terminals. One is a MySQL terminal, one is a TiSpark terminal, and we'll just be querying into the same data source to see how easily you can change something and see something from the other side and do analytics on top of it. Okay? So bear with me as I figure out the resolution of this thing. Oh, can everyone see this okay? Probably not. I'll zoom it up, I promise. Oh, it's really small. Okay. It's a little bit better? Meh. Well, that's not better at all. Okay, so these are just like the three terminals. So on one of the terminals, I'm just going to fire up. So I already get cloned TiDB onto my computer, but that's literally just very simple. Close. So now TiDB is getting spun up. Dun. All right. So before we should get into some querying, I want to show you guys real quick. So in each of these deployments, we have installed a Cortana deployment. So that is a localhost port 3000 just by default. And you can log in just using admin, the default password and user, to see and monitor this current cluster right now. So if we go into, say, the overview, not a whole lot happening because there's actually not a whole lot happening. If you go into the cluster for TiDB, you can see the available sizes and all this kind of information. So feel free to play around with this as you add more data into this cluster. It's really fun. I do it all the time. So that, just to give you guys a little bit of flavor. Again, localhost :3000, and you're there. And another thing I want to show you real quick is a visualization tool that we made ourselves. So this is defaulted to 8010, and you can actually see a visual of these 3 TiDB clusters, and you can even see kind of their back and forth communication. This is our little in-house database thing that we made. If you zoom in a lot closer, you can see these little blocks. So these are mostly empty, but the green blocks, if you can see them, are the region leader blocks, and the dark gray ones are the follower blocks. And as you add more info into this, it'll become more interesting to look at. But this is something you can play with. Okay? So back to our query. So now we launched our TiDB cluster. I'm gonna launch our MySQL thing. So as you can see, launch MySQL, and you can see the TiDB version here. This is our current version, so version 2 RC4. And here is just your good old MySQL. And I'm also going to launch Spark. Here. Yeah, Spark in. All right, so we'll let Spark kind of run a little bit, and then let's see what is actually in our current MySQL. So we'll be playing around with this particular database called TPCH001. Okay, so just use TPCH001. So now we'll use it, and then inside this particular database, we have a bunch of different tables called like nation, line item, like I don't really know what's in here, just like a bunch of sample data, right? So inside nation, we can do, see what's in here. Okay, just a list of countries with some comments and random stuff in here, right? So all this stuff is stored in TiDB, right? It's not visible, but it's in TiDB. So now we have Spark up and running. I'm just going to run a few commands to essentially connect TiSpark to this Spark. So this imports TiSpark. I'm going to do this. And then one last thing is to map this TiSpark instance to the TPCH001 database that we were talking about before. And if you want to run your old Spark SQL, let's select from the same nation. Oops. Server. Oh, you don't need the. It shows the exact same data, right? And we can actually put in some more complicated queries in here as well. So there's this one particularly gnarly looking MySQL query that we can run that produces this kind of data. And if we run the same query in our TiSpark instance, it should give us the same data. So on this row is the same, on this here. So let's say if you want to change something in this table, so let's say update, what do we call it, the nation table, set the nation key to 111, and then let's just do and name, let's just do Argentina today. Argentina, all right. So if we do select nation again, Argentina is changed to 111, and the same change should be immediately reflected on the Spark side. So do TiSpark SQL, select from nation, show first 20 result. Here you go. 111 is here. The change is made, and you can query it however you like, depending on how TiDB changes the data. Okay. So that is pretty much the gist of my demo, but you can of course play with this until you are, very bored. But it's actually really fun to do. So again, thank you for giving us a chance to host this talk and to let me give this talk. If you want to do the whole Docker Compose thing, just Google TiDB Docker Compose, you hit it. Obviously visit our website if you actually want to request a demo that is of a much larger size than Docker Compose, so we can actually talk about how we can deploy this in AWS and Azure, maybe for your production environment and things like that. And check out our repo and hit me up on email, Twitter, whatever you feel like it. Okay, that's it. So happy to take your questions. Yeah.
Do you have any benchmark, like comparison with other stuff, like just MySQL in general or other key value storage?
So we are actually going to be releasing a set of benchmarks with our 2.0 release. So that'll come to you probably in the next week or 2 weeks or so. We try to be pretty careful with like benchmark because it just looks like it could look like benchmarking. If you just pick the problem that makes you look good and then makes the other guy look bad, and then you actually use it, and it's actually not the case. We don't think that's good for anybody, really. So we try to be very rigorous with the way we, not just do these benchmarks internally, but actually promote them to tell people about it too. But yes, it's coming to you in the very near future. Stay tuned.
How about the for-text search? How about the for-text search? You talk about the logs you saved. Can you search through the logs? Or
you mean in terms of the Mobike situation?
Yeah.
Yes. So what they use, I don't, of course, know exactly how they use it, right? But the part that they at least are willing to disclose publicly is that they use a lot of our system to store their log, to be able to identify, basically troubleshoot their problems very easily, right? The unlocking and locking is one pretty major thing that needs to troubleshoot, but there are probably other things that they're looking for constantly, right? Using our system to be able to do that very quickly.
So you mentioned one region is 10 megabytes.
Yeah.
Do you need you store 10 megabytes key value pair in RocksDB?
Correct.
Okay.
Or using TiDB in Rust. Okay. Right. Yeah. So that's like the amount of data they're letting us, store for them, right?
So basically, you store 10 megabytes key value pair into RocksDB underneath.
Yes.
Okay.
And I don't know exactly how many nodes or how many machines that makes that happen, but you can kind of think about it. If you have a really good SSD that's 2 TBs or so, you have a cluster of those, and yeah.
So you mentioned SSD. Are you literally just required SSD to work, or you can work with Spinozix?
We highly recommend SSD because that's what we built this system to optimize for. You can certainly use any kind of disk you want to use it, right? You can deploy it, it's gonna work. I just don't think you're gonna get much out of what we built if you don't also provide pretty decent hardware to support it. Yeah. And that's something you run into a lot, right? You talk to people and this thing doesn't work really well, and they're like, well. Yeah. Any other questions? Yes.
So when you say you can query like SQL, how do you query by a column? That's not the primary key.
Right.
You actually break the computation and do the search.
Right. So currently, the way it stands now, right, you still have to query by the key value first before you get to the column that you need, and that's certainly not column family support. And we are actually working on that. And we would love to get people to help us work on that. So if you have some free time to contribute to the TiDB project, please help us do so. That is definitely a big need, right, for a lot of use cases that want columnar support. And we want to get there. We're just not there yet. Yes?
Version 1.0 was released late last year. How did you go from that to 100-something users in production now? In such a short span of time.
Right. So the company started in April of 2015, right? And our 1.0 was October 2017. So it was 2.5 years of work going into that release. And some people may say that's really long, some people say it's really short. But during that time, everybody on the company is very engaged with the community. So a lot of these users that converted to in production almost right away, they've been kind of testing out our stuff for a long time. Right? They've been engaging with the product, with the community for a long time. And these are people who, companies, not just individuals, Right? Like Mobike was testing out our stuff prior to our 1.0. They just weren't ready to put it in production because we weren't even ready to say we were ready to release it yet, right? But as soon as we kind of opened that spigot, we're like, all right, we're ready. You just have a lot of kind of incoming interest that was sort of accumulated up to that point, right? And it's just kind of happened that way. So we still get like issues or like PR requests from companies that have been quietly, secretly using us for like, months, and they just didn't tell us, and they're like, oh, we have this problem. It's like, oh, you could have told us a little bit earlier, and we could have helped you out a little bit more. But that does happen from time to time. Yeah. Any other questions? Or you can take it offline too afterwards. Yes.
So, like Mobike, for example, uses this as both an analytics store and a client-facing.
Right, and like an OLTP workload. Right? Yeah. And there's another actually really interesting use case that was published on Datanami a couple months ago. It's by this company called Yiguo, which is, I call them like the Instacart of China. So they just deliver like fresh produces, on the e-commerce platform. And they use us also in this sort of HTAP way during especially peak season, when they're running deals. Like, the Black Friday of China, for example, there's a lot of stuff that they analyze constantly throughout the day, and that's what they use us for in that fashion as well. So, yeah, you guys should check that out. It's really fun.
Do you have any, controls around, if you have a really heavy OLAP query that is not affecting, your transactions, your production, serving traffic?
Right.
Any sort of controls around that?
Right. So the way we at least provide that for you is through the placement driver, where we kind of take a snapshot, right, of like, okay, as you run this really complex query, like this is the kind of the time snapshot in which you're running all this data on, and kind of whatever happens afterwards of the transaction, won't be part of this particular query that you're analyzing, right? So you won't be kind of taking up resource first of all, and also bumping into potential transactions that could be happening during that time. And that just kind of depends on how long this query actually takes before you can run the next one, for example, with more fresh live data that could have been accumulated in the meantime. Cool. Well, find me on Twitter, wherever, email me if you have any follow-ups. Love to get you guys involved any way we can. Okay? Cool. Thanks.